Okay, thank you, Tim, for having me for a second time. As I said the other time, I think it's really important what you do here. This started more or less in the pandemic time, but at the time, but we, with experience, we have tested that. In fact, it's very useful for the community. It's a way to share stuff. And then the other time, I talk about Pharo, the release that was coming, and this time we had more or less the same idea, but we were not ready to talk about Pharo 13, which is the upcoming release. And then we decided to do something that, in fact, I do believe that it's meant to be an important part of the Pharo ecosystem for the reasons that I'm going to expose in my talk. Uh, but well, I'm going to just start sharing this thing. I think I hope you see it.
Yeah.
Is my talk that is a talk that, as you can see, I don't know if the mouse sees because I like to be able to.
We can see your mouse. Yeah, we can
Okay, because I like to be able to to do this kind
point
of
at those. Yeah.
just. But I took the same presentation that I give to ISUG because, in fact, the main concerns that I'm talking is the same. But of course, you have to forget that this is this and now is UK stock, the UK stock, and uh, I'm going to use the same presentation, but I want to be a little bit more in deep than what I have the opportunity. I don't know if you're still with me because my screen froze. Yeah.
No, we're still here. It's good.
Okay. Okay. So, well, as I say, my talk start because with this. This is a poem of John Donne, which is No Man is an Island. And the reason why is this is because I do believe that not just Not Man is an Island, is also No Smalltalk is an island. When Smalltalk started, it was meant to be an abstract machine that will be replaced, that will be from bottom to top in a fuel computer, like the ones that they made in Xerox at the time. And that's reason, for example, why Dan Ingalls say that an operating system is a bunch of stuff that does not fit into a language, and there should not be one, because what they had in mind was something like a Smalltalk that was going to go to every what comes to was going to be in the occupying the full computer, and of course that will be a super powerful tool. But the problem is that the world has moved, and Smalltalk didn't took that place, and the operating system start, and then the original idea of Smalltalk, which was we do everything in Smalltalk, was was difficult to fulfill. And well, the other reason is as a Smalltalk, then Pharo is not an island either. And let's face it, we today we have a community, a size of community problem. We will not be thinking on talking with the external world if we will be able to do everything that we need inside Pharo or inside the Smalltalk in general, but we can't. We have communities that are small, and then we cannot do everything and have a thriving community like that. So that's why we have FFI now, and that's why in Pharo we pushed FFI so hardly during last years. This is more or less the history of FFI as a fork of Squeak. When we fork, Pharo had an FFI plugin, but it was very, very limited. It was just a thing that allows you to call some functions with a lot of work there, and it had no callbacks, which became later very important, and it was not portable at all. To fix a little bit this, Elliot Miranda implemented in 2011 the Alien framework, which implemented callbacks, and it has an alien way of behave, a design, because it was functions as objects. So you needed to program an object that it was going to call. Finally the API, but it was nice. It was nice and it was very fast at the time, but it was not portable as we wanted. Then Igor, I don't know how it's pronounced. I'm sorry. Implemented Native Boost as a replacement, which was a very nice design, which using ASMG. So he was generating the assembly, and it was callbacks. It was, but it had some requirements like an executable memory manager, which is for many considered as a security issue, and it was also not portable. It was so not portable that when we transitioned from 32 bits to 64 bits, we needed to rewrite it. And that was the origin of UFFI, which is meant to it means unified FFI. Why it was unified? Because it was mixing three things. It was mixing the design of the upper level of Native Boost, which was very nice to use, but it was using all the FFI plugins for the callouts, and it was using Alien for the callbacks at the moment, and it was very hard to do. So for that, we finally migrated to libFFI, which is an external library, which right now works very well. And a couple of years later, we added threading to FFI. So now we have a very, very, very mature and reliable infrastructure that we have been used there. But there is still a missing part, a very important missing part, is that you have to create manually all your bindings. So if you want to do a binding for a C library, you have to create by hand all the functions, all the structures, all the enumerations, everything. You have to do it by hand. This is very, very, very time consuming, prone to errors. It's complicated, and it's complicated. It is complicated, and then to maintain this binding is also an effort. We have, for example, that problem in libgit, which libgit is powerful library, but they have the bad attitude of changing the structures in the middle, which I don't know if you know. If you change the structure in the middle, then since they are just positions in a byte array at the end, you mix everything, and then you have a lot of crashes. So we need to do manually. Each time there is a new version, we need to do manually a review to see what changed and apply it by hand. So, and then I remember that Mariano Martinez Peck did years ago something that was called FFI header, I don't remember what, which basically was using libclang by using clang directly to generate information of the headers, and he was as an XML, he was reading that, and he was generating bindings with that. And I say, well, we can do the same. And that's Pharo-CIG, which means C interface generator. It's very simple. The idea is that you take a C library, you execute some kind of magic, and then you can have the same the bindings in Pharo. So how this magic is? Well, is, as you can see, not so hard. We have something that I call a receipt. Is the instructions that you need to do to generate using clang a translate unit, and visiting this translate unit, you can generate all the parts in Pharo. And it's very easy. It's very easy once it works, of course. It's very easy to use. But the work was a little bit hard to achieve. So let's start with the demos, which is the most important part. The first demo I have, which I did it already in issue, is the Raylib demo, which was something like, I don't remember why I put this. This is Raylib. This, as you can see, this is how a recipe looks. Recipe looks, sorry, no recipe. I have French mixed now and with Spanish and with everything, and then yeah, my accent is not the best, but okay, that's how a recipe looks. You have your generator, of course. Since we do not have namespaces, we have prefixes. You have to declare the prefix. You have to declare a generic library name that is going to use for doing some naming too. But you can, for example, but it uses also as a default name for libraries using the conventions of Linux. For example, if you let that, it will be called raylib.so, the library in Unix, and like that. Raylib, sorry. But but you can, of course, declare the name that you want to do. I don't remember how it's name is already there, but it's okay. And then you declare what the headers that you are going to import. Here we have 3 because Raylib requires them. And we can add some instruction to libclang that works like clang in a command line. Where is the include path? I don't know if you know something of C or GCC or clang, something. I'm going to assume that you know it, but you can interrupt me anytime and ask. And this is an important information because since we have a threaded FFI, we can declare that the library runs in a separated thread. Right now, we have different strategies for that. The default strategy is same thread FFI execution, which means that the callouts are executing the same the callouts and callbacks are executing the same thread as the Pharo VM. And that, of course, is blocking. So it's many times not very nice to have. And you can declare any kind of workers that execute, that will create a physical thread in the VM that where you can run. And you have main thread. Main thread is important because, for example, 99% of the graphical tools required to be running the main thread of a program execution. So what happens here is that we run Pharo in a worker thread, the Pharo VM, and the graphical part in the main thread. Since this is a library for doing graphics, you need to use main thread, and then we just generate. I can execute it. This time it's going to work because in the issue it didn't work, but I will not do it because it takes some time. And why? I already generated. Later we are going to generate something smaller on that. But this is what it generates. First, it generates, of course, a library. A library, I don't know if you know UFFI. To execute a call out in C, you need a library which declares, for example, this thing, which is where you can find the library. And if I inspect this, you will see that it found it in the system because I installed. It has different strategies to do it, and this is something that I declare also for this, but I will explain later why it's useful this. Then it generates, since this is a C library, all the functions are generated here, also in the library, in the public protocol. And as you can see, they are just regular regular FFI calls. If you are have work with FFI, with UFFI, you know what you are seeing. If not, believe me, this is translated to a call out regularly. And you have different kinds of mappings. This is, for example, this is a structure that you can see. It is also auto-generated, taking a different kind of data from there. Here is a very weird structure because it has an array of 2 of matrix, an array of 2 of two array of 2 of matrix, and then a set of array of 2 of float. How can I do that? Know that because this is created also by the system, and everything is put in the declaration part, which is here in the type def. Type def is called like that because it's called like that in C, but it's just a share pool that initializes all the different values that have. This allows me to have a mapping almost identical in the FFI call to the C declaration that we have in the headers. And then you can do nice things like, for example, this example, which is here, and it allows you to execute things. I'm going to execute it, and that should work. And voila. As you can see, that works. And the mapping is nice. You can right now, for example, the naming is generated automatically with an algorithm created by me. The naming of the functions tries to resemble the most possible the C counterpart, but also it tries to be a little bit more like in like in Smalltalk. And then you have things like you have results like this, which is not so bad, I think. Of course, if the library is well designed, your naming will be better. One of the things that are not implemented yet, but I want to implement, is to be able to give an strategy made by you to the recipe, so you can pick the naming. You can do the naming as you see it fits for the library. Of course, the purpose of this recipe is to generate this library, which is completely independent of the generator. Once you generate it, you do not need to load the generator in the system. It's going to be a package that you can install in Pharo without any other utility. But okay, so as you see, this works. This works fine. The 3D example, I will not do it because it's not working correctly, but it's executing, but it's not showing anything. And I think this is nice, but this is, of course, for doing an example of a nice thing because it's a gaming library, and I just have been called. I need to leave for 2 minutes. It's okay?
Yeah.
Just think on questions. I come back.
This is the quick put the child to bed interval. He said it took a while to generate it. I wonder how long it takes to generate what looks like quite a complicated library, actually. But I suppose it's probably only a couple of minutes.
I found it pretty fast when trying it. I don't know if it changed in the last few months, but
he's probably just more worried about us just sitting around while it's generating, I suppose.
Yeah, it's just not instantaneously.
Okay, I'm back.
Oh, that was fast.
Yes, it was faster than preview. I will not complain. Okay.
So
So
to generate this Ray lib, what would it have taken? Like a couple of minutes or something? Just
yes, it's really. Sorry, I didn't say it, but it was in the presentation.
That's okay.
Oh no. But now I'm going to take more than 2 minutes. Shit. Sorry. Sorry for the language. No, I need to restart the connection. It's okay?
Yeah.
Sorry, I will be back in.
We'll join us in a second.
No,
Okay.
2 minutes were realistic. Sorry. I'm leaving.
I didn't think the naming was too bad, actually. It seemed fairly sensible from what we saw.
Yeah, I sometimes had some problems with naming. Some C libraries have weird names for the functions.
Yeah.
And then you get lots of duplication. Yeah.
It is great, isn't it? So you don't have to really read the header file or source file. This program takes care of you. I think this is really great. You really don't have to study header file or source file. I think your generator takes care. And now, after that, you can just use as a Pharo method.
Yes, that's the idea.
Yeah.
Yeah.
Does it handle C++ or have to be C library?
Well, yes, but let me finish my presentation and you will have an answer.
Okay. Keeping us on the edge of our seats here now. That's excellent.
You were asking for questions, eh?
Yes. Yes, kind of. But that specific question will have an answer, and a good answer, I think.
Better questions, unanswerable ones.
Yeah. I'm restoring my screen, sorry. Because I had as I say, the real problem is that sharing screens with Wayland sessions is not always super easy. So I hope this is not going to.
Yeah, we're back.
But now it's okay. Okay, so I was saying another example that I have, which is actually a real life example, something that I did for Sabine. Sabine, I don't remember her last name, I'm sorry, but Stefan can say it because he knows. She needed to validate XML, and we didn't have XML validator implemented in Pharo.
Sabine Manning.
Voila. So as I was working in this, I decided to use her as her problem as a use case of this, and then I map libxml2, which is a very complex library. If you see. If you see like the amount of things that I generated is 9,544. And that is also a huge amount of functions that are very complicated functions. And since this is not so well designed about naming and data as RayLib, the names are ugly, but they are there. And you have not just the library, but a lot of opaque objects, enumerations,
Right.
and structures, etc. It's a very huge, and it allows you to execute this code, which is also, as I say, is ugly because the naming there is ugly, and I cannot do. I didn't implement yet a strategy to do a better naming that is appropriate for libxml. As you can see, I will not explain everything. What this does is to open an XML, open an XSD, a schema definition, and then it executes using a callback validation, and if there is an error, it gives you a callback with some data that I didn't map to anything more interesting than an ordered dictionary, because this is a script to test. And if you execute this, of course, it will give you a empty collection because there is no errors there. But if we put an error here, for example, I put blah and blah with an error, and I save, and then I execute, and then I have perfectly validated my XML. I have the error. So, and for example, right now this is already in production. Sabine is using it for her project in her enterprise. So at least it's already a solution for a real problem of one of the people that uses Pharo, which is basically my objective as Pharo core developer. And
so the method that you showed us that you're calling, you wrote that method, but it's using all of the things that were generated from the native library. Is that what I've
yes.
Yeah.
Yes. Sorry if I'm not clear. This method is something that I did.
Yeah.
But it's using the auto-generated. I don't know why people does this. Well, okay. Sorry. I'm not very happy with the message browser, and we are going to change it in Pharo 14 because we didn't arrive in Pharo 13. But it's halfway done the replacement. But okay, yes, everything this is auto-generated. I use this.
So for example, like the XML init parser is.
Yes, if we see this is this.
Okay, yeah.
You can see it, and is returning a pointer to this, which is also, I don't know what. No, it's not here, so it's not mapped here because it's in the SharePoint, which is a structure. No, yes, it's a structure.
So you basically have to just wade yourself through the README file of the library, pick out the name, the C names that they're using.
But I want to show something fun because I was experimenting to the talk today, which is this. I told ChatGPT to read, where is this? From one of my examples, to read one of my auto-generated files and generate me the code for the example from this. And it's kind of, I think it needs a little bit more training, but it's generating something that is more or less useful. So he understands that it understands. Let's not anthropomorphize a language model, but it understands the bindings, and it generates some example that I didn't have the time to test if it works because there are some things that are not well generated. I need to train it a little bit more. But we could use this to translate all the examples because this, for example, that is here is one of the examples that I took from the libxml type site, and I just translated it to this because it was to show. But anyway, so this is already then an working example.
And it just worked. It was like what that method, you didn't have to, like, what was generated
yes,
on the native
it
method.
just worked. I didn't need to do anything.
No memory error issues or anything. It cleans up nicely, and I guess if she's using it, she's
Of
happy.
course, this is programming in C with Pharo. So
Yeah.
yes, if you need to do a free, you need to do it by yourself. If you need to free some memory, you need to do it. And that's something that, for example, but here, this is the cleanup parser, for example, is something that does a free,
Right.
somehow, and this kind of stuff. But free text reader, this is a free from the. So you are still programming in C. It's not going to handle it's not going to have garbage collection of the other side. But for example, in the RaveLib example, I'm going to reopen to show it. I did some. No, it's not. Okay. I'm going to show. I did some manipulation to help handling it but I'm going to show it later.
Okay.
Okay, let's continue. Other stuff that I did is libSSL. libSSL is again a huge library. This I'm going to show the example very fast because it's the concepts. The concepts that I want to show are already explained there. But the only difference, this is the recipe that we use. And the only extra thing that it shows is that it allows you to declare some type defs of things that you don't want to include. For example, I know that I'm not going to use pthreads here, so I just map it to void, and that will that will generate. And this is something that is a void inside a structure that, for some reason, is not mapping it correctly, and that's an error that I have to fix. But until I fix it, I also can declare it like this, and it's going to pass, because it's an error because libclang has some complications that I still didn't learn to handle, because it's very complex as a tool. And then this thing generates, for example, again a good amount of functions, structures, enums, and that. And it allows me to do this demo, which is also something that I copied from the site. It encrypts, it allows you to encrypt using RSA method, because it was the easiest example. And then I can just declare this. This creates all that byte array that you can see. And then if I decrypt it, well,
Yeah, cool.
it does it. And this is very useful because OpenSSL is a very complex library with a lot of methods, with a lot of algorithms implement that everybody uses, and we do not have that. And if we need to do that by hand, it's a pain.
Yeah.
It's a real pain. So this is a real life things that are already working, and there is people already using it. So let's continue. Let's continue a little bit. There is not so many. Oh, no. Why it didn't? It decided that the first. Okay, continue like this, because I say I show this, the RaveLib. This is things. This is complications that I need to resolve. I do not need to talk this, but there are a lot of complications due to some problems in CLang. For example, the fact that if libclang do not understand a type, he does not throw an error. It just gives you an int, which is a real problem, because then I need to disambiguate every int I receive in my data. I need to verify if it is a real int, is a real integer, or is something else. And then I map that by hand. I go to check the sources because I have access to the sources. I see, and I replace it if needed. But that can causes problems in the future. So I have this, and then, as is asked, there are a lot of libraries that, in fact, are made in C++. And C++ has a problem, that is, there is opposite to C, there is not a standard ABI that we can map, that we can take, and we cannot execute, we cannot get object reference and send message to that in C++. So it's very painful. So we want, anyway, a C++ interface generator. Something that you put some C++ library there, some magic happens, and then you have that. And well, what we do here is this part here. It's more or less the same, as you see, is a C++ library generator that generates a translated unit, and that is traversed by a Pharo visitor, which uses generators and templates. But this has to happen in an intermediary file. An intermediary file, which is generated using, is also automatically generated using a bunch of rules, which are very complicated. we do the same. This is, by the way, the same thing that everybody else does. If you have Python that has some way of communicating with C++, behind the scenes, what they do is to generate an intermediate file, and they pass through that. There is no other way to communicate with C++ for real. But this has, the C had some challenges, some small challenges. C++ has a lot more. And that's a real problem, because they have things that are stupid, like things like structs are classes and classes are structs. So you have, in Smalltalk, we need to be able to map or a class or a struct, and then we need to identify which one it is, and we do it right now. If it has public fields and no functions, then it's a struct. but in opposite, it's complicated, but we can determine what it is. And there are a lot of other problems, like the problems that they have namespaces, and they have aliases, like which is like a type def in steroids. And they have templates, and template classes, templates functions, templates for everything, and that's complicated to handle. And then it's the standard library that many people uses, especially in declarations, and since we are going to use those declarations, we need to know what to do with that. But I have to do that. I succeed. This thing is mapping C++ libraries, kind of. Some C++ libraries. It's a working process. It's not finished, but it's possible. And I have libnoise as a demo, which is very interesting because it's a very nice library. Very well designed. So it allows you to have a good case of test for that. So let's see it directly how it works. It's not here. No. So let's do it. I'm not generating here because it takes, but I wanted to do a small generation. But so this is generated using this recipe, which is very simple because it does it fast. It does it without a problem. This generates all this. Generate, of course, the library that we see, that we already see, even with some public functions that are used, but not many. Most of it is doing in these classes that they generate. They have classes inside namespaces, and here I create a namespace that is a package tag with some description that I'm going to use it later, which tells me something what it is, and then there is the classes. The classes, since list noise is so well designed, they have even comments of the class that I can put here, and they have also comments in the methods that I can use. And I can map one-to-one the classes with some prefix, of course, generated. And as you can see, they have different things. And the interesting part here is this. This is the method, the function that we are calling. Let's see how that function is, how that function looks. See. Noise. Let's open it with this. You can see this, no?
Yeah.
Okay, well, the things that I generate is first a header file with all the declarations. These are a lot of type declarations that are actually classes. That's why it's type def to void, because they are opaque objects at the end. So when I use it, it's void pointer. But I want to be able to declare them with the type. And then you have a lot of function declaration with this pattern that I took from GTK, that they use this, that they simulate some kind of object-oriented programming with C, adding prefixes to this. This will be the module, and then below is the class, and then the function, and then they receive as first parameter self always, and then the rest. So I map each function in each class. I map it to something of this, each public function, because if it is not public, I will not be able to use it anyway. And then in C++, for example, let's see, in the C file, I export it as an extern C. Let's see here, it's an extern C, which is, as I say, the only way to do this. And then each function is mapped like this. Some are some require casting, but these are the functions. Let's see in a class. In a class, I have the new, that it will create it and cast it back to a pointer, to a pointer to go back to go to Pharo. And then I receive the self as a void pointer, which I do a cast and I execute the method. And this, each C++ class will have a representation of this way. So
these are generated bindings, are they?
What? Yes, these are.
This is all generated by, right? Okay,
yes,
got it.
Auto-generated too. You don't have to do it. And of course, not everything parses, but right now. But the idea is that we can parse everything. And then you have this. And as you can see, I can do a lot of how this is how the initialization works, and that everything works fine in this case. And I have, for example, this that I executed. I can execute it, and this is going to generate. I didn't explain what libnoise is. Libnoise is a library to generate Perlin noise, which is procedural, regular numbers. It's a library that is used to generate, for example, maps like this that using for gaming or for different kind of things.
Okay.
So, and it creates a terrain. This generates like a planet with everything, all the properties, the water, the mountains, the thing, and the idea is that then you do a game there and you can recover. And in Isug, I even did something that allows you to traverse that in a map as a map, but it's not running now, so I'm sorry, but
So the external C stuff that you generated, do you have to then compile that into a DLL that you can then call?
yes,
So,
it has to be compiled. Look at this. In the libnoise, you have this, and that's why this works, because the generator, if you do give it the instruction, he will also compile it. It will generate the bindings, it will compile it, and it will put it here in your generated libraries in a transparent way.
Oh, so it does all of that work as well. Okay.
Yes, of course you have to have libclang. You have to have libclang installed in the system. I cannot do magic. Even if I did a slide that says magic, it's not magic. It's a lot of work. But,
wow, that is nice though. Yeah.
And then it does this. And you see, here it's pointing to my generated bindings library. Other thing that is interesting of this this C++ stuff is that when you use a C++ library, you often use another C++ library. You use namespaces and things that you do not want to map again. So I added also a way to use the namespaces already generated. For example, here I use noiseutil. Noiseutil is a library used to generate that bitmap that I show. It's just an extra, an utility that they give you if you want to show that, because what they do is to give you numbers of this. This is just to show you what will be the result of what you are generating. And this is nothing. So I have in the recipe the ability to declare the namespaces that I already have generated, so they are not regenerated, because otherwise I will multiply everything, so I can reuse that. And for that is that information that I put here, because he says with this he can know which is the module which is the C++ module that I'm using, and this is the prefix that I need to use for that, the classes or the functions that I'm generating there, and that. So he knows how to do it. And as I say, that works. So how do you know that I'm not lying? I have this example that I tested just 5 minutes before, which is ecal. Libical, is to work with calendars.
Right. Okay. So iCal. Yeah. Okay.
iCal. Sorry, my English is polluted. I have an accent. Okay, so and where did I put it? Let me 6C library generator, new. I already did it. Why I do not have it in my... I don't want to retype again everything. Oh, for some reason it's not there. This is libecon, but no, libecon. Let me take the prefix equal import lib equal ical.h generate. I think this should work. No.
Maybe something.
No, it didn't work. Or yes? No, because there is an error. Remove this thing, I think. Again, no, because it's too fast. This takes some time. Let me.
It's all right.
Hmm?
We understand. It's always the demo gods that kick in.
Yeah, well, no, I need to do it because otherwise it will not be a real presentation. But this...
You have to point it to the source.
I need to find my example equal. This. Now it's taking some time. Now it's taking too much time.
Can you explain the library name? How significant is that? Where does the library name get used?
Sorry?
So
Again?
if you look in your recipe,
yes,
you specify a library name. Now, where do we see that library name?
I think I have a default.
Does that come out?
I think no, because we need to get it there. We need to later be able to find it here.
So it's the name of the DLL, basically, is it?
Yes, it's the name of the DLL. You need to be able to find it
the
here.
name of the DLL.
Yes.
Right. Okay.
That's why, and then I already. So, and this is the map done, and let's. And it does kind of fine, even with some nice comments. And then let me do this. I have a give me a sample equal example in C. Let me see if it does it. No, this one no. Let me, because it's going to be a lot more. A lot. Give me an example of parsing a calendar event with lyric. This is just so I have this. Okay, I'm going to do just the first part, but voila. I wanted this. So let's say this is this. And let's leave unique instance. How is called the function? It was this one. And voila, parsed.
Oh, wow.
So a just generated library. We can continue taking stuff, but if you want, I can take an event, but I don't know. Anyway, this is more or less my presentation for today, I think.
That's cool.
Let's continue. I already showed this. Well, so how it is? Well, from C++, there are problems. One of the problems is that not all C++ libraries are designed to be used outside C++, which means, for example, we have a lot of libraries that are white box frameworks. That means that they require you to extend a C++ class to start doing stuff. And we cannot support that right now. It is possible, but we cannot do it right now. Most libraries have a naming problem. For example, especially in the variables, which is something that we use to generate naming, and that is not always good, and that generates things that are very, very ugly. But one thing that is important is as it is right now, the framework, it does not remove and recreate. It just overrides what it is there. So you can build on top of it and commit. You can build your own abstractions there, and they will not be removed if you generate a library for a new version, for example. So that's kind of nice, I think. So, well, and finally, it has a good test coverage, not as good as I would want, but it has some. 60% test coverage is not bad, I think. I want to go to 80 minimal, but we are not yet there. C mostly works. There are some corner cases that I cannot that I'm not handling right now, but most of the time it works perfectly. As you see in live I map also NCourses before for this talk. The NCourses library is just the real problem is that I was not able to find a nice example fast to show it, but okay. But it works fine. But C++, I'm still working on it. My way of work is I take a library and I parse it, and I resolve the problems of that parse because I cannot. I have another job. Even if I do believe that this tool has the potential to be an important part of the Pharo ecosystem, especially because like this you can maintain a lot of bindings without a lot of effort.
Yeah.
And then that will solve one of our biggest problem, which is lack of options for doing a lot of stuff. I cannot work all the time in this, and then my way of work is just parsing on demand and resolving the problems. And once the problem is solved, well, I expect that will solve problems for other libraries, and I will have less issues on the time, because otherwise solving all the things that C++ provides is just too much work. So better doing it iteratively and by needs of people, which is at the end, which is the purpose of this framework. And the other problem is that the documentation is, well, okay, I'm not good at writing documentation. let's say that I need to do it, but it's complicated. So okay, thank you for listening to me, and I hear your questions now. Yeah, that was the end.
I have a question. How do you know if a parsing doesn't work?
How do you know that? Sorry?
How do you know if the parsing does not work?
It gives you an error. So libclang gives you always a cursor, and you iterate on the cursor. So the parsing does not work when as this is small, when I do not know what to do with a type, for example, that I receive, or when I generate a wrong name and then it fails in the compilation of the bindings, for example. Most of the time, it's just a type for, especially in C++ right now, the most important problem is the types that are used in declarations from a standard library. That kind of type of SharePoint or moving references and all that. I do not know what to do with that. and then the compilation fails.
Okay,
Or the sorry.
Thanks. Very nice.
And then, of course, you still don't know how to actually use the library, and you might still just crash your image or hang or forget to free something.
Of course, once you are using FFI, you are in C world.
Yeah.
If you crash, you crash.
Yes. So I've learned to save a lot.
Well, but I'm experimenting with another frameworks that allow you to execute your test your in another image. So if it crashes, at least it's not crashing your image. Yeah. It's crashing another one. And then I have something that is already more or less working, but that's very experimental and not ready for consumption.
Hello, there's so many paths you have to specify, including the source files. Is there any restriction of the order of them, or you can put any random order, everything is included, then that's fine?
Well, right now you can put it in any order because it will do a translation unit for each header file, which is wrong, because then it should be a forced order, because sometimes you need the declaration of the previous header to be able to compile the other header. But the idea is that you need to do, I should be able to do a unique translation unit with all the headers. And in that case, it will be with a forced order. But right now, it's not needed.
So you suckling all your files, then you start mapping activity. So order doesn't matter.
No, right now, no.
Okay. But you may change?
As I say, I'm trying, one of the problems that I'm trying to solve now with this is that sometimes, especially in C++, I do not get the right type, the right type, and I get an int. and I get an integer because libclang gives me an integer. But that's because libclang is not knowing the type to give me. And that might imply that I need to declare the header before and make Silence to know that this is the header he needs to check to resolve that type. So yes, that might change, but I'm not sure because I didn't solve that problem yet. I don't know if it's
I
clear.
think it is so great, makes I think almost Pharo and C, borderless, and should be advertised and documented, where lots of examples should publish, I believe.
Yes, you're right.
If you get into the nooks and crannies of a library, like sometimes when you're using a library, I don't need to use like 30% of it, and that's usually the more complicated bits. So will it, if it gets stuck in that 30% bit, can you still use it? Like, just sort of get it. I guess you can ignore bits, right? You can just tell it what to include and then ignore the other bits. So at least you can use the basics sometimes and not worry so much about the.
Well, one thing that, yes, one thing that you can do instead of just import a full header, you can say from, for example, this will not have sense, it's just to show how it works, from import and a list of things of entities that you want to import. You can do that. It's in fact,
so if it's struggling on some of the complicated stuff, you might be able to
and then
avoid it. Yeah.
Then you just bring what you want from a header.
Okay.
In fact, I'm using it someplace. Let me see. For example, list from the standard library. I'm just bringing a standard array because the standard library is here. I'm still showing, no? Yes. Here I'm doing this. This is in a test, but I'm testing that. And then here in the XML.
Right.
This changed. This is no library name, but okay. And then I'm just bringing the things that I need here, because I didn't want to bring everything. So yes, you can do it. And in fact, the thing is, you still need to do a recipe. You still need to maintain that recipe eventually.
Yeah.
If version changes and that. But my take is that it's a lot easier to do that to maintain bindings for each thing that you want.
Yeah.
So you maintain one or the recipe, because at the end the recipe is a little bit how you will do to compile the header to get a file, because you need to be able, libclang needs to be able to parse it correctly. For that, it needs to have all the information required. So that's why you have things like C include path on that, so you can give it all the information that libclang needs. So you still need to do that, and it will be still needed. But as I say, I'm very happy that I'm producing something like libxml and it's used, and OpenSSL and it's used, and I do not have to do the bindings myself.
No, that's very cool.
That's something that I.
What about other languages? Are we going to start seeing like other libraries in Rust and these sorts of things? And is this applicable to those other languages?
But yes. Well, right now I can get everything that libclang can parse. I can get it inside. In a way, probably, for example, if I decide to parse Objective-C that libclang does, I will need to do another generator in the Pharo-CIG, but it's possible. For Rust, I don't know. Eventually, what I do think is Rust, when they want to publish things, they publish a header, a C-compatible header. No,
Okay.
I honestly I didn't check out Rust.
We're
But
probably not there yet, but we in a few years we might be, mightn't we? Because it seems
yes, but eventually someone will give me something like libclang that will be possible to be used to get the information I need, even for Rust.
Yeah.
And then it will be just to extend the framework.
Yeah.
The same that there is libc library generator. It's possible that eventually there is the Rust library generator. One thing that I want to solve, for example, is for GTK. GTK has this G object system, which is like they simulate like a object language with C, and they have a lot of information metadata that they produce to make object-oriented languages able to parse that data and generate their bindings. And right now, I want to do the same for us because we have GTK bindings, but I do it by hand. And I can tell you that it's a painful work. So I want to spend time to extend this, at least for GTK right now, for G object system, because it's not just GTK, it's everything done with G object system. Later will be something more eventually. Honestly, I will want people to use it and to help me develop it a little bit more. I know Stefan made me a pull request. I didn't accept the pull request, but I did apply part of his changes in the sources because part of was good and the other was good too. But I'm still thinking that I need to implement other things instead. But okay.
Yes, I noticed a problem, but I did not really find the nice way to solve it.
Yeah, okay. It's complicated, but it's fun to see people interested and contributing. The license right now is LGPL. Why? Because once you generate something, you don't need to have that installed. So it's not going to pollute anything if you use it. And second, because I want to kind of force people to contribute back if they improve it. But it's as soon as if it is not fit, eventually I can change it again for meat, which is the preferred license. For now, it's LGPL, but for that, because I want to enforce the contribution back.
Yeah, that's fair.
And because it will not be a problem for the generated bindings. So
that the call outs, did it also how do you handle the callbacks? Is it handling callbacks as well?
Yes, we handle callbacks.
Okay.
But in fact, a callback is a function pointer in C side. Yeah. So we just need to detect that this is a callback and then use it. It's a little bit raw right now, but I had an example in the libx.
Yeah, your
XML there was, and there are some others right now I do not have in mind, but here there was the usage of a callback, and I know there are some others because there are several others. This is the one that I have in mind right now. And how is this in the declaration of this? Let me check. Declaration of this is, you see, this is a function, and then I know that this is a callback, and then I detect this is a callback, you see?
Yep.
So I detect it because it's a function pointer, so I can know what that is a function pointer and say, well, in our side, this is going to be a callback. What I want to do, and it's not there yet, but it's very possible, it's just that I didn't have the time, is to generate a special callback with the signature already defined. Because if you see here I have to declare the signature of the function. There is no reason why I cannot have already this type defined also in Pharo-CIG, so people does not need to use it. They can just use that function type, that callback types. It will be in our side, and that's all. There is no reason why to. It's just a time to implement it. Something else?
What Pharo version are you using? This is Pharo 12 or 13. Which one is good for this?
This will work in Pharo 12 without a problem because it was developed in Pharo 12. But Pharo 13 will work too for the moment. And there is no compatibility problems with this. I know there are some errors some possible enhancements in FFI that I detect doing this, or I knew it sometimes, and eventually I might decide to apply it, and that will break compatibility. So that's one of the reasons why I when it's not absolutely necessary, I do not do it. I do not apply the changes. For example, I want that if a function returns null for something, I want to have a nil, and right now it's not the case. I have an external address that is null, and these kind of things that are enhancement of how things work, but they are not really necessary, and that's why I'm delaying apply that, because I do not want to break compatibility. So right now, from Pharo 12, Pharo 13, Pharo 14, that will start in 1 month, will be okay without a problem. And I believe Pharo 11 will work too. I will not go more behind that.
You try to apply to, for instance, Windows side as well, because sometimes you have different naming prefixes, other things. For instance, back then I wrapped a lot of Windows functionality in the OS projects. Did you try that on Windows headers or COM headers and other stuff already?
Nope. I will be glad to try it if you give me one small window header that I can try. Most of the times it will work, but it might be some special cases like the handles and that Windows tends to have, but there is no reason why it should not work, because at the end is C. But if you give me a small library Windows oriented, I will test it. Torsten?
Yeah, we should try.
Yeah, but there is
I mean,
no
a lot of functionality on things. For instance, you could access a lot of stuff from C side. For instance, in Windows in general, and which are not portable. Because mostly the things like Ray LibreOffice that you tried are portable C that you have on Mac, on Unix, and other. But you try some Windows stuff that is not portable. Let's say in C it also looks different, and it would be interesting to know how much you can handle with the library to wrap some of these standard Windows APIs and other things down even to COM, or with COM even to .NET. Or even you could have for Java. Java also has a GNI stuff, and even the Java Java VM is a DLL basically. So you could have also more language interoperability possibly with that one.
Yes, that could be, but I would say
mostly
that
the problem of time.
Right now, if libclang can parse it, I'm confident that I can do it. If libclang cannot parse it, we need to find the way of actually doing it, and that's more complicated. But in general, C headers, are usually compatible. Is in the insides of C where Microsoft has a tendency of do their own stuff. But I don't know. We need to try. I know that lib noise works, for example. I tried it in Windows. My parsing of lib noise works.
It's a cool project. Thanks.
Thank you. So
How long has it taken you to get this far? Like, how much work has been involved here? It seems like a ton, actually. I mean, obviously, there's years of like, you know, on the shoulders of giants sort of thing. But this incarnation, is it?
the problem is that I developed this in 6 months, but not full time. I work. In fact, the first library I parsed was libnoise. Was a C++ library.
Right.
It has not even C, and I took 5 days in parsing that. All the rest was all the details when I started to parse other stuff.
Right. Yeah. They're making it.
And then the refactors and that.
Yeah.
And I took no less 4 months because I started in February 24, and I presented already in this issue, and I then not move a lot because this is not public information, but I usually got 1 month free for what I want right after the release.
So okay, just
each year the agreement that we have is okay. After release, I have 1 month to do what I want.
Oh, I think that's fair enough to recharge and get your energy back. Yeah, that's great.
And that's where it born last year. This
nice
in my month of relax, and then and I will have again a block of time to work on it next month because the release of Pharo-13 is going to be half of May. We are delayed, but we are almost there.
The release moments are, of course, famously known for creating so much space to do other things.
Yeah. Yes. But,
It was amazing. I mean, you know, I'm impressed. Very, very, very nice piece of work, actually. Thank you for persevering. I mean, it's a hard problem, but like you said, when you get it right, it means that it opens the door to lots of interesting pieces that the community doesn't cover. So
yes, that's my intention.
Yeah, I've been looking at using libSSH to make installing remote machines easier.
Ah, that's a good idea.
Because that's what Ansible is using. And it would be nice if we could do something similar from Pharo.
Yeah, indeed. Okay.